Uh, Let me first of all would like to thank IPI for giving me this opportunity and allowing me to make this presentation. I would
Yeah, yes.
Is it okay?
Yeah, it's perfect. You can go ahead.
Okay. Thanks, Rajesh, for setting the note for the morning session. I would like to briefly introduce the company which I'm promoting here in India. I've been associated with them since 2012, bringing in their technology. For the benefit of the people who may not be so well conversant with Fonky, I would quickly run through to get an idea about what Fonky is offering, and then we'll go to the topics.
Mr. Milind, you can also switch on your video so that your
Okay.
face will be visible for the audience also.
Okay. Yeah. Okay. Is that okay now? Are you able to see now?
Not yet.
Not yet. 1 second. You cannot start your video because the host.
Okay.
Okay.
Yeah, perfect.
Okay. Okay. So as I said, Fonky is one of the leading extrusion machinery manufacturers from Southeast Asia. They have been into this business for almost 6 decades, almost 60-year-old company. They are based out of Tainan in Taiwan, which is southern part of Taiwan. They are, as I said, since 1953, they are into this. It's a family-owned company. It's a third generation which is into this business, employing about 200 people. And more or less on an average, you can say 42 years of age. We have sales across the globe and one of the leading extrusion machinery suppliers. And 80% of the business comes from the repeat business, having sales office across the globe and including India, Fonky India. Primarily, it has been an extrusion machinery builders covering everything under extrusion, but over a period of time, they have consolidated themselves and offering blown film line, blow molding machines, sheet extrusion, glass film line, and extrusion lamination machines. On an average, the company's turnover has been about 30 million USD. Primarily, as you can see here, the distribution of the equipment across the globe. So we are spread across the globe, as you can see. This is as far as the product mix is concerned or the product lines are concerned. So we have primarily the HBA, HBB, EHA, and ABI. These are the major products, which is the blow molding. I would say blow molding products, which contributes to a major sales of our company. Just to get an overview, so we have complete extrusion lines for different specifications, outlooks, material handling. So we have a very good, strong base here in India, more than 40 machines of the extrusion lamination, especially in packaging industry. We also offer blown film lines, complete range in blown film lines, right up to 8-meter wide, up to 1 ton's capacity. We have blow molding range. We have a very wide range blow molding, right from, you can say, from 50 ml right up to 1,000 liters. The product line is divided basically into different product application based on the end use applications and the capacities. So we have the HBA series, which is typically for up to 30 liters, which is a direct extrusion. It could be monolayer, could be co-extrusion, mono and multi-layer. Then you have the continuous co-extrusion, which is, Raghu has already highlighted that, so I'm not, so it's basically the new trend today in the extrusion for larger containers especially, which used to be an accumulator based designed earlier. So that's the similar what we have here. As far as the continuous extrusion, you have the accumulator head designs also, which is going for a lot of other applications, automotive as well. So you have the accumulator-based designs. You have a PC polycarbonate containers. So this is the, as far as the blow molding is concerned, the sheet line for various applications, for disposable application, as well as for white goods industries, luggage industry, stationary applications. So these are the other product line. You have the cast film line, which is for the flexible packaging industry by and large, which goes as one of the layer as a sealant layer or as a packaging layer. And the main reason is for our success and being in this market for so long is we keep on continuously innovating, price to competitive ratio, I would say, in terms of investment to output, excellent service support. We have a service support here in India as well. And we have a good support team in all respect for sales and development. So that's the primarily, as far as the company is concerned, it's ISO certified, C certifications. So we work together with the customer and help in cost reduction, energy saving, and I'll come to more details as we come further into this. Coming to blow molding, yes, this is a complete range that we offer. And as I mentioned earlier, so this is one of the product line. I mean, what you see here, I mean, primarily as a blow molding, but what is the demand today from the market? What is the market looking for as a solution from the industry? You want basically low maintenance, low power consumption, cost efficiency, less noise, less labor, environmental friendly, high productivity, no pollution. And today, less labor is becoming more and more important, and the energy savings. How these are being addressed in various models, I'll try to touch upon that. And these areas which are we have highlighted. So here you have the range which offers complete, as I said, from 50 ml to right up to 30 liters, primarily for high output monolayer or co-extrusion. So it could be 2-layer, 5 layers, 7 layers, could be multi-head, multi-station. So depending on the productivity required, so this could be a solution to it. You have blow molding, which are accumulator based design. So basically where the short weights are quite bigger. So the Parisian extrusion time is longer. In such cases, you have the accumulator so that you push out the Parisian in a short time. So you have for various of these application. So especially going to the products which are there under accumulator head design. So if you're looking there, you're talking of products which are for, let's say, road barricades or dividers. Then you have garden furniture. These are some known brands. These are the products which are used. Then you have some kind of packaging boxes for your LCD and TVs, basically. So large components which need. Then you have some automotive components, some high pressure vessels, drums, different types of drums you have. You have liners, and here you also have, as Rajesh already pointed out, the trend towards now going towards continuous extrusion blow molding. So that's another solution. You have the post-cooling devices to, as rightly Rajesh pointed out, to bring up the productivity of the machine. You have different requirements on the product to be fulfilled so that you have minimum post-operation. So you want to have all these incorporated in your process of manufacturing itself, so that there's a least post-operation time and the product is more or less ready to dispatch to the customer. Similarly, you have the accumulator design also for the automotive industry. The air ducts and the components are very important, and some of the customers who are leading in this market are using the technology from Fong and have multiple installations at multiple locations, and you have such intricate components being made. And that's the beauty of the extrusion, blow molding technology. So various intricate shapes and containers or products, basically various types of ducts. One point, yes, definitely the air ducts business, irrespective whether the vehicle moves to, trend is of course going to be more towards e-vehicles, but nonetheless for the air circulation, air conditioning, these duct business would definitely remain. Yes, so this part of the business is quite important. The spoilers and the side plates, some of the tanks, commercial vehicles, these are some industrial floats. So what is basically requirement for these kind of products, and where do so you need basically a hydraulic power pack when if it is an accumulator based design. You have accumulators of different capacities based on the article short weights. You need more space for loading such components because they are much more bigger in terms of dimensions. Short weight may not be so big, but the important is the dimensions of the product being much bigger. So you need much bigger platen size. Also, secondly, tie barless design so that you can easily load the molds and take out the molds. You need good power pack units so that you can achieve the faster cycle time and the locking time. The robotic system, as I mentioned, the requirement is to have less dependency on labor. So you want to have automatic handling system to take out the devices. You have certain products which may need different types of blowing arrangement, need not necessarily be always from a top blowing. There could be a side blowing, could be a middle blowing, could be a bottom blowing. So you have different blowing systems, and you also need deflashing system online so that you can basically have minimum operations on the equipment, and the product can be delivered directly to the customer. Now, most important here is the machine also needs to be versatile in terms of handling the polymers, because there are different range and applications depending on the end use application. The material characteristics are required. So flexibility in terms of handling the polymers. You need a robust gearbox. So we have aligned with reliable suppliers as far as the supplies of components are concerned. You need good feeding system, continuous dosing systems. So you have groove feed sections. It's a barrier screw design. The idea of having a barrier screw design is basically to ensure three things. Basically, you need to have a homogeneous mix. Secondly, you are often using different polymers, or you're using master batches. Some master batches may have a different melting point as compared to the base polymer. Now, therefore, sometimes there is a tendency that the material may not completely melt. And these particles may come along with the polymer unmelted, and you find a concentrated or a specks which is coming here, as you can see here, unmelted particles. Now, with the designs of the barrier screw, what happens is, this is the flow of the direction from left to right. So the material, as it goes further in and it progresses melting, you have in the compression area the double flights which is created. The meaning is that as the polymer melts, as it progresses down, you see the liquid portion is separated from the solid. And this you can see here, there is a double flight here, one which is marked with the diagonal lines on it, on the flight, which will be slightly smaller in diameter, as you will see here. So the liquid will overflow and go into the separate channel, which is in this portion. And as you go down, the portion will increase and the solid will remain unmelted separately. So the two compartments sort of are created as you progress. So if you see here, the distance between the solid, this is the solid portion and the liquid would be here. As you progress down, you will see the liquid portion is here and the solid is only small. And as you progress further, so you basically ensure that the no solid particle, unmelted particle goes further into the stream or into the downstream. So you are ensuring the material is thoroughly mixed and homogeneous. I mean, at least you are ensuring that the material is mixed here. And then the next stage is where you have the mixing head at the end. So you ensure that the material is thoroughly mixed in terms of the, let's say, master batch which you are using, or sometimes you are using a regrind. So the mixing is happening, uniform temperature is achieved, and then you are pushing it further into the system further down. So you are ensuring that you have a good mixing and homogeneous melt. You are getting an unplasticized material are not being pushed. Similarly, you have the accumulator die, which is basically different designs depending on what application it is. But important is a FIFO system, so first in, first out, so that the heat history of the polymer remains the same. Of course, this is for the single layer, and you ensure that the uniform flow, there are 4 spirals depending on the die diameter or the die head, and could be 4 or could be 6 different sizes of accumulator head, so different capacities in terms of short weight capacities. Of course, the other important aspect is the programming or the Parisian programming, which is important in terms of having a uniform distribution, which I'll come subsequently more in little detail, basically to control the wall thickness of the container so that you get ultimately a uniform wall thickness. You have the also one is along the length and the other is along the diameter of the Parisian that you want to, or the along the length of the tube that you want to vary the wall thickness so that you get ultimately a uniform wall thickness article. So you need a post handling system, robotic system. The clamping system, we have different systems based on the article size and the platen sizes. So you have a robust, very good clamping achieved on the article, and especially when we are talking of long articles, to have uniform distribution of the locking force so that the mold does not open out and you do not get the burr or the marks of the parting lines. So to ensure that you have an additional supporting locking device so that you get the mold is thoroughly locked, especially for larger articles. Here you can see more bigger daylights and more space for mounting and easy loading and mounting of the load molds. This is the additional locking device which is provided so that when you have long articles, though the short weight may not be very high, but because the article is bigger and have a bigger surface area, so you need additional forces to make sure that the articles don't open out. Also, you need different types of blowing arrangement. As I mentioned, sometimes you need unscrewing. So like, for example, typically in the L-ring drums, where you have the neck, which is basically has a screwing arrangement. So you need to have the blowing as well as the screwing and unscrewing devices. You have pinch off device, the Parison stretching device. Sometimes you need to even stretch the Parison so that it stretches along the width of the article. You have various sub-suppliers to ensure that you have a reliability, consistency on the equipment. So you see, find the basically more reliable consistency of the equipment. Molds, which plays a very important role in terms of the productivity. So different efficient cooling system is important as far as the design of the mold is concerned. So also the water circulation, and we have our own mold maker with whom we cooperate. This is of course the Parisian control program and the international standards as far as the safety norms are concerned. You have accessories like post cooling device, pneumatic device, or handling system. post-threading or trimming system, leak tester, inline inkjet printers, so stacking leak testers, and inline crushers, grinders, so that the whole system can be integrated and more or less can be a scrap-free production. We have wide-ranging references across the industry. The next important development, and which rightly today is the trend towards the electric machines. Just as you all are familiar with injection molding, so also the trend is also in the blow molding. And the reasons are primarily to save the energy cost, clean room, less maintenance, especially with the hydraulics. And so you have less maintenance. This is typically a layout of one of the electric blow molding machines with a 3-layer design with a double station. You can see here different layouts. I mean, just to give you an idea. So of course, once again, touching upon those points. So basically, the electric machine is another solution to the market, primarily. Okay, 1 second. I just wanted to run one movie. 1 second. So the undercut handle is also pinched off. Leak testing. Weight checking of the article. So here, so this gives you a briefly an idea of the how full electric machine was. This is the layout. It's a compact, more or less everything closed loop, no manual interference with minimum, and with the recycling, rescrap generated, whatever pinch off is recirculated into the system. So basically, you can see our main idea is to save. One of the main reason is for saving the power vis-a-vis the hydraulic machine. So that's one idea. It reduces definitely, therefore, the carbon footprint. Noise levels is reduced. So that's one major savings in terms of the full electric machine. So also the co-extrusion, which already my former speaker has already highlighted in terms of cost savings. So that's another aspect. This is a typical specification of the line. In fact, this machine was running during the last K show with 257 bottles per hour or containers per hour. So this is an overview. As you can see here, we also basically offer the direct drive for the extruder so as to reduce the frictional losses, and no pulleys or belts, so no maintenance, wear and tear. Ceramic heaters, again insulated so that the heat losses are reduced, as you can see here also. Screw, I already discussed. Of course, a metal separator to ensure that the no metal goes into the machine. Extruder nodding, which is also again motorized controlled. You have the die head, which is again 100 point or 200 point depending on the article. The Parisian programming, PWDS and SFDF. This is basically to control the wall thickness, especially for the articles. And this is, I'm coming subsequently here in the further presentation, how exactly it helps. This is a view of a clamping, which is on a linear bearing. So there is a less movement, less vibration. This is a clamping unit. Very important is to make it lightweight so that the energy consumption is less. At the same time, the structures need to be rigid to hold on the pressures and the longevity of the machine. So there's a reinforcement given to the platen so that at the same time it is lightweight as well as gives sufficient reinforcement and can take the loads, sufficient space in terms of platen size so that the mounting of the molds, more area is available. We also work with mold makers from different suppliers, and especially with in terms of especially in terms of the metallurgy and also in terms of the cooling efficiency, the proximity of the cooling channels besides the metallurgy. Blowing pin, which is also controlled, and because some processes need two-stage blowing or one stage, and secondly the circulation of the air within the blow pin, because the polymer is inside hot and it gives away a lot of heat, so the air which is coming in has to be circulated so that it brings up the higher efficiency in terms of cooling of the product before you can take it out. So at least it has taken the firm shape. You have the deflashing unit. So, so you can remove the pinch offs. So no manual interference is required. You have the photo sensor which senses there's the pinch off is taken out. There's no leftover. So it also gives the sensing, so there's no damage to the parts or the molds, grippers for taking out the material or handling, weighing scale to ensure that the weight of the article is within the control, which indirectly reflects if there's any process variation also. Post cooling devices also has helps to help in accelerating the cooling. So you are reducing the more time of the operation available on the machine and post cooling subsequently. Depending on the article, there could be 2, 3 post cooling devices. You have leak tester, weighing scales, and you have the residual conveyor for carrying away the pinch off, the grinder, the electrical cabinet, also tropicalized for especially country like India. There's enough safety in the equipment, also interlocks so that nobody can enter the production area while the machine is in operation, otherwise it will switch off. You can, it's a CE certification with all the safety parameter, with all the safety grills around the machine. Of course, there are optional equipments available depending on the customer needs. The most important was one point which we work with for the PWDS with 4-hammer. And this basically helps in two things. One is primarily to reduce the weight of the article and improve the efficiency and give you a better uniform wall thickness. This is typically what is done. As you can see here, the gap which you see here is what is maintained with the help of, here you can see the gap which is more uniform compared to here you have more, less and more. So this depending on the article shape, and you will see in the subsequent slide how it is being utilized. So where, for example, here you see the wall thickness here is there. So if you have less material here is okay, because there is nothing, the stretching is minimum. But when you go to the corner, the stretching is more, and therefore the more material is on the corner. Now this is what you are seeing across the radial. So also along the length of the parison, the similar situation, similar control is required, because somewhere here you have the handle at the, in between there is nowhere. So you need to have a more material when you are coming and extruding at the, let's say after the first 10 mm. So you need to have more material here. So this control is done with the help of PWDS and SFDA. Or here you can see how the control is done. You can see here the thickness is much more without using a PWDS and SFDR, but with PWDS and SFDR, you can reduce the unnecessary weight which is there. So this helps you to bring down the unnecessary weight of the article, and secondly, improve the cooling time of the product. And here you can see, this is the, what I was trying to say, you can see here, this distance is shortest. And when you go to the diagonal, which is more further, so the stretching is more. So this can be controlled with the help of the PWDS and SFDR. This is just to give you an idea how it looks like without and with PWDS. The post cooling device, okay. Leak tester, I think we have touched upon earlier. Also, the cooled air system, basically to control your blowing, especially. So you are circulating the air inside the container while it is being cooled in the mold before you can eject it out. Dehumidifier to ensure, especially in a country like India where it is, humidity is quite high on, especially on the coastal areas. And I would say more or less 50% of the country is on the coastal lines. So there, especially the humidity being very high, you have the sweating problem. So you have the dehumidifier, which ensures that at least in the cold mold area, you have the dehumidified air so that the sweating issue is not there on the mold. We also have the industry ready for industry 4 with the SCADA system. So you have interfaces, and easily accessible for the entire machine control from a single point, and the operator can control various points from a single control point. Of course, there's a alarm history, so you have the historical data alarms also stored, so one knows what has happened in the night or what were the problems in the night shift. If the manager comes in the morning and wants to find out what was the problem and how long it was taken to rectify by the maintenance team, so all that record data is available, the maintenance records, and it gives you prompt. Also, it prompts when there is a requirement for the maintenance. It also monitors in terms of the power consumptions and any unusual peaks which you see in your cycle, the trend, that gives you an indication that there's something wrong, so that the corrective action can be taken. Something preventive maintenance and helps the operations. Automatic visual metrology, this is again another quality parameters. So basically it visually measures the wall thickness, and it tells you if there is a variation in the temperature or the profile of the your Parison programming. So then you immediately know that this would reflect on your product. So therefore it gives an alarm immediately, so that your product production does not go waste and does not have a complaint from the customer. Thank you. I think if there are any questions, we can take up.
Thank you so much, sir. I request Mr. Arun.
Yes, thank you very much, sir. On behalf of IPI and all the participants, I would like to thank both